Dear viewers and subscribers, welcome again to our YouTube channel Max the Service. Please subscribe and press the bell icon to receive all notifications regarding any video we are uploading on this channel. To start with the microservice architecture discussion, before that I just wanted to remind that in last session we have covered GitHub action workflow. Apart from architectural design discussion, where you can see now, it has been discussed step by step and with example, you can watch and enjoy, you can watch and learn. In my last session, I have uploaded all the series, all the parts of this complete full GitHub action workflow. So today we are going to start working on microservices. So what are microservices? There are different perception, different thinking, because what from the definition point of view, it is an architectural approach where an application is structured as a collection of loosely coupled, independently deployable. Each service focus on specific business function and can operate autonomously, allowing for greatly flexibility and scalability. Actually, this module design enables developers to build, test, and deploy service independently, often using different technologies like programming language tailored to each service need. So this is very simple. What is microservice? It depends on you. Let's suppose this one is my service. I am going to design this microservice. Okay, this is what I can decide its boundary actually. Okay, what its boundary I am going to decide. And also we have different approaches. Either I am going to design this business requirement wise, or modular design wise, or event based design. So there are different approaches. It's also depends on what, sometimes you go from design and develop from monolith to microservices. When your monolith application becomes huge and you are not able to manage, and even there is a one fixes, minor fixes, you have to down the application and then you take some downtime and then you can go and deploy. To avoid all of this, the new design patterns came into existence, which is called microservice. And now it's up to you. Don't get it complex. Don't stick to the definition. Enjoy and relax and think what are you are going to define. Actually, there are number of parameters where I can share. You can easily design your service, and that will be your microservice. First thing which you have to notice, that will be single responsibility. Okay, our concern. Even if let's suppose you have listened that we have login microservice separately, log out, sorry, after login you have sign up, you have authentication. These are different concern. Your sign up, login, or authentication service will not be working together. Yes, if you have monolith application, then you can have. Otherwise, all three services will be working independently. Okay. Here, let's suppose this one is login, this one is sign up, and this one is auth. So definitely you can assign all three these services to different users. Okay, login, sign up, and then you have auth. If you have time, you have team where you can if you feel something improvements, if you have something to design from the scratch or fixing any bug, A separate independent service can be maintained, managed, deployed without having impact on other services. So this design called microservices. Same goes for the rest of. Okay. If I go another aspect, this is your single concern. Because let's suppose if you are going to design a payment API gateway, then that's purpose or concern should be concerning only payments related, not any fetching the account detail, updating, making credit, debit, process, whatever else you have to take care of it. Another is discrete microservice boundaries. So any microservice must have clear boundaries. Okay, you should define clear boundaries. If I'm going to design a login microservice, its boundaries should be clearly defined before starting. Okay. Another way to think about this principle is that microservice must be well encapsulated. There is no interference, functionality, redundancy. There is no involvement with the other. This means that all logic and data relevant to a microservice single concern must be encapsulated into a single deployment unit. Like example of units, discrete deployment like our Linux container. Okay, so even you are going to design these are because these are the very common services. I will put in like user service, service. This user service will be adding, deleting, updating only user. There will be no anything related to, like if you are going to authenticate user, you must not go with this implementation. You will not be implementing any authentication criteria which will become redundant, because if you have already authentication API, authentication service, then this user with this detail, it should be go to authenticate first, or your login can go to authenticate, then it can go to fetch the user detail. Okay, this concern should be very clear. Here you can see if someone is uh, like let put example. If someone is trying to log in and here is your application, here anyone from web or mobile or any web, it will start login. First, you have to go to authenticated. Okay. And then if it is okay, then you can add, update, delete, whatever, second step. So when I'm going to define user service, I have to take care. There is nothing, any logic or data code base related to authentication. Everything related to authentication must be done with authentication service. So this is the purpose of designing microservice. It should be managed, deployed, tested, everything should be done separately. Another aspect I should be consider, like in, let's suppose I have this authentication service or user service or any other service, let's suppose we can add another number of services. Then I must consider, okay, if our service is working on one environment, let's suppose, which is Linux, okay, Linux based, then it should be executable, should be runnable on the Windows, okay. If I have more than one authentication service, okay, if I run same service on Windows based Windows operating system, then it should be running successfully. A transport microservice can be moved from one runtime environment to another with little effort, just deployment and configuration. Perhaps currently the optimal form of transportable microservices is a Linux container image. Okay. Then another aspect we have like Let me put it as a duplicate. Okay, another aspect we should consider, which is carry its own data. Let's suppose I must have own data of login, then own data of user service, then own data of, okay. I'm using draw.io. You can also use this one for if you are uh, interested in the architecture design, you can use this portal. Okay, then here surprising thing is when sometimes developers uh, avoiding to do all of these things because they don't want to maintain user data if you are going to use user service, and also they must have some user detail in the login database, some user detail must have in user service, also might be possible in authentication service. To avoid this, most of the development team avoid to do all of this because they have take care to maintain all the data because they don't want to have redundant means duplicate. Some data is placed here and then here and then here. If there is any user specific data changes with this database, it should be updated here as well. We need to take care of it. So these are the concern we have to take care. So this is very important, considering when you are going to design microservice architecture, you must be thinking about the database. Every service must be owning its own database. Okay, and then another example, imagine an e-commerce application we are going to design. The application might have microservice that manages customer profile, like you have user service. Okay, and when the principle that every microservice carries its own data is forced. Okay, it's quite possible that the purchase microservice might have data that is redundant with the customer profile. Okay, if let's suppose another service we have purchased, this might be possible. This purchase service have also data of users. So this is actually such data redundancy goes again the grain of developers who embrace the dry principle, like don't repeat yourself. Okay. Another important thing is inherently ephemeral principle. This principle actually is that microservice is ephemeral, means that it can be created, destroyed, and republished on demand on a target easily, quickly, and with no any side effect. Let's suppose this service can be tested, deployed, maintained independently. We don't need to take care of other services when we are going to work with user service. We have to take care of any functionality which is redundant with any services. This should be done separately. If one team is working with this user service, then this team don't need to disturb or need to communicate with the other team to have some dependency. Let's suppose I'm going to deploy the service. If I have a requirement to redeploy this login, down this authentication, whatever, this not be a good approach. This not be a good architecture decision. So these are the very common cases. These are the very good example which I have shared with you. Actually, another concerns defining our characteristics of microservice. Uh, just to conclude that each service is lightweight. Okay, add minimum as possible code, add minimum as possible logic, independent, okay, and loosely coupled business unit. Loosely coupled mean it is not coupled with another. Let's suppose if there is business here, in purchase. Business means some logic we implement. Okay, here I'm going to have. Okay, okay. Each service is responsible for a single part of functionality, business capability, and does it well. Okay. If anything related to purchases should be considered in this purchase service. If something I'm going to uh, develop and maintain in user service, then that will be not good because whenever we have any uh, deployment, bug fixing, enhancement with purchase, and if we need something to develop, something to enhance, something to fix also in user service, then we have to review our design architecture because there is something not loosely coupled. There is something not single responsibility. Another thing we have to take it, each service can pick best technology stack for its use case. Let's suppose if purchase service is e-commerce space and I developed it with any cloud-based technology, serverless containerization, then this not dependable that all other services should be like same. If I'm going through authenticate using any auth provider, then this can be Java based. Okay, this service can be Java based. This service authentication can be cloud based auth provider. So all these should not be technology dependent. We can implement any service in any technology, but we have to consider business requirement as well. Sometimes it is possible that our business requirement can be fulfilled with the technology which we are going to choose, but we are going to choose a different one, which takes some extra effort. Another thing, each service has its own DevOps plan. If I'm going to implement CI/CD, I can implement with any service. Okay, there should not be any hurdle, any problem. As we have covered in last session, CI/CD pipeline with GitHub Action, or because we will not be going to implement CI/CD pipeline if we have implemented GitHub Action with this service, then if there is any challenge with purchase, then we have to consider like Jenkins, any other technology which provide all of this. And that would another requirement, another team we should need only for single change. Okay. Then our each service deployed in self-contained environment. Okay. Let's suppose I'm going to deploy, let's suppose our service and I have a virtual machine like here. Then please keep in mind that I will not be deploying this service on the same virtual machine or same instant or same container should not have more than one services. Every service should have its own deployment running environment. We may have one server, but deployment container should be different. Because let's suppose I have deployed in a server auth, which is providing auth provider, and also we have deployed the same server on that same service on that server. Then what happened? It will happen a very big failure. What? Let's suppose if this service goes down. Sorry. Yes. Let's suppose these two services are in one container. Any issue with that container, we will be losing these two services at the same time. if we are going to shut down once due to fixing or enhancement or anything new deployment with user, then definitely we will be getting down that container automatically. Our provider will not be available. So we need to take care every service have its own container environment. Another very important thing is each service should be capable to communicate with each other. Okay, let's suppose if I'm going to after login authentication, then I'm going to purchase something. This instead of this response should go back to user interface. Then we need another API to get the user detail. Once authentication successful, we can ask user service to provide the data for further user to get purchase done, and then we can respond back what user was logged in and what other detail have done with. Sometimes you logged in and other detail get pop up automatically, address, phone number, email, whatever. So this should be considering at all. Each service can be communicated. And another thing, service communicate with each other by well-defined API, smart endpoint, like simple protocol, REST or HTTP, gRPC, whatever. Okay. Another thing, each service is responsible for persisting its own data, as we have discussed, and keeping external state if multiple services consume the same data, such as situation are handled in common data layer. Let's suppose you are going to down this whole service. Okay, then if I'm also using the database of user in place of purchase database, then this service will be up, but this service due to this service unavailability database will not be available. So I have to take care that if something is going to down and I need purchase service up and running, then definitely we have to take care this concern as well. Okay, so this was very interesting and a very important discussion because in nowadays there are a number of definition and discussion going on microservice architecture. So I decided to share with you. This is very simple and there is no any need to go into detail. Just define your boundary according to your requirement and according to your design pattern. Either it is a domain driven or event driven or business wise. So whatever you need, you can go. Another important thing, while summarizing your process, you must identify first service and then you second should be designing API. Keep in knowing that whenever you are going to design a service, after designing you must define your API, determining how services will communicate with each other, what are the parameters of each service should have. All those things will help you to give more insights and you will be able to identify a lot of when you go with this approach. Then after that you will be choosing your own data storage, and then after that you will be ensuring resilience and fault tolerance in your microservices. You must have implement exception handling, you must have an API gateway circuit breaker. So definitely we will be going to do all of this. So in next section, before starting microservice architecture, I decided to explain you in detail how we can think about the microservice, what are the concerns we can have before starting the microservice architecture. So in next session, we will be defining our core pillars of microservices. I am going to use Spring Boot cloud, and for that what pillars and what components we need I will define and explain in detail what are the purpose of those important component of microservices. I will explain in detail and we will try to develop something from the scratch.
Okay, please subscribe my channel if you are not subscribed yet, and also do like, share in your circle these videos, and also provide your valuable comments. And I hope you will be liking and sharing so that I will be continuing with rest of the technologies and tools sharing with you. Thanks.